Now, what the hell is a derivative? Well, a derivative has two uh, definitions. And the first one says it's the slope of a line tangent to a curve. So my illustration is right here. And as you could see, at a point, because a tangent line runs through one point, you have this curve right here. I mean, basically, you know, it's related to the derivative. How could we, predict some change instantly at this specific point? Second definition is also what is called the instantaneous rate of change, right? So in chemistry, when we talk about chemical kinetics and how the concentration of reactants vary as it pertains to time, well, at a specific point during the reaction, we could actually calculate how the concentration changes. So those are the two formal definitions of what a derivative is. Now let's look at the rules. Derivative of a constant is zero, right? So in this case, any number, the derivative of that is zero. Let's look at the power rule. The derivative of x to the n is equal to n times x to the n minus 1. All right, so what does that mean? If you have something like y is equal to x squared, well, dy dx of that is just 2x, right? Because you're going to bring down this 2, which that says y the n, and then take 1 minus that. Look at the constant multiple rule. Well, derivative with respect to x of a constant multiple rule says that, okay, well, cx to the n, derivative of that is just a constant multiplied by the derivative of the inside, right? So in other words, this is saying something like this, right? If you have y is equal to 4x squared, well, dy with respect to x is just going to equal to 8x, right? Because you're gonna bring down that 2, you're gonna multiply by the constant outside and take 1 minus that. Let's look at the exponential rule. Interesting. Derivative with respect to x of the exponential function e to the x is actually just e to the x. So that is just something handy to know. It's very important. Product rule says that derivative with respect to x of u times v is equal to the derivative of u times v plus u times the derivative of v. We'll look at later on what does that mean. Let's look at the quotient rule, and it says that derivative with respect to x of u divided by v is equal to the derivative of u times v minus u times the derivative of v divided by v squared. All right. So let's look at a couple of examples. I have this first function here. F of x is equal to negative 6 x to the 4th minus x to the 3rd, negative 3 plus pi. One thing I want to talk about the notations, and you'll just pick up the notation as we go along. So one of the three notations is usually we do something like f prime of x. Right? If you want to find the first derivative, we put in that prime to indicate that it's the first derivative, right? So this one says that, okay, well, we could bring the 4 down. This is actually a constant multiple rule. So 4 times 6 is just 24, but we also have that negative here. So this is negative 24 x to the 3rd because we subtract 1 from that 4, right? We're also going to bring down this 3. Now this 3 right here will be a plus and a minus. So this is just going to be minus 3x to the negative 4, right? Because we subtract 1 from that. And interestingly, this is my answer, right? This is my answer right here because the derivative of pi is 0. Why? Well, pi is not a variable. Pi is actually a number. It just, it's in its variable form, but we all know pi is like 3.14 something. So that's very important to know. Let's look at the second one. All right. Same thing applies. So y prime, this is also another notation. We'll bring down this 5. So this is going to be 5 halves x to the 4th power right? Minus, well, we'll bring down to 4 again. All right, so 3 times 4 is negative 12. X to the third, and this is just minus 2 because derivative of x is 1, right? Derivative of a variable is just 1. So this will be your answer right here. Let's look at the third one. A little weird numbers, but nothing too complicated. So we're going to bring down y prime is going to be the square root of 3, x to the square root of 3 minus 1. That's a number, but we want exact answers, right? Plus, well, again, we'll bring down our pi times our x, and this is just pi minus 1, right? Plus, the derivative of e to the x is just e to the x, so this will be your answer right here. Let's go to the last one. Well, this is also an f prime, so we're going to start off with that, all right? So f prime of x, well, this is x to the e, so we're going to bring down our e, so this is e x e minus 1, right? See that? We just bring down the e because e is a number, but it's a 2 point something, and it's a decimal, so we want exact answers. So e come down times x to the e minus 1, right? Minus, now interestingly, again, this is just a number, so we'll bring down on 15, so this is just 15 over 6, x to the 14, and we could probably simplify this to 5 halves. So f prime of x will now be e minus 1 minus 15 over 2, 5 halves, x to the 4th. Right? And those will be a couple derivatives.